Hello, let's continue our Sudoku adventure with Night Vision by Gene. So we have normal 6x6 Sudoku rules, which means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these blue lines in the grid. These are region sum lines. So let's just do this line because it's the most complex one. Well, what it does is it gets split into segments every time it crosses a box border. So I'm going to use colors here. We call this the green segment. We cross a box border, making it the purple segment, cross again, getting the orange segment, cross another time, we get, say, the red segment. So why are we segmenting it? Well, within the same line, all of the segments have the same sum. So if this was, say, 2, 4, that would add to 6. That would put a 6 here. This could be maybe 1, 5, and then this could be 2, 4 again. So this would be one way to fulfill this line. And then that doesn't mean that all of them add to 6. This could be, I don't know, 5, or I don't know, this could be like 3, 6 adding to 9, and then these 3 would add to 9, like 1, 2, 6 or something. So just because these add to 6 doesn't mean segments on other lines add to 6. Just within the same line, they all have the same sum. All right, and then we also have these crop key dots in the grid, making the eyes. It does really look like night vision goggles, doesn't it? But anyway, so white dots, digits separated by a white dot are consecutive. Meaning like if this was a 2, this could be 1 because 1 and 2 are consecutive, or it could be 3 because 2 and 3 are consecutive. Black dots, digits separated by a black dot, have a 1 to 2 ratio. Another way to put that is that one of them is exactly double the other. So if this was 2, this could be 1, meaning because 2 is exactly double 1, or it could be 4 because 4 is exactly double 2. And that is it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, I do think the place to start is this line. We can do a few things with it. This is a really common pattern that you'll see, at least in Adventure, probably elsewhere. But in 6x6 it's very powerful. So the first thing is that whatever this sum is of the segments, it needs to be a single value sum. So I mean, the sum is 1 through 6 very naively. But we need 2 different ways to sum to that number, to sum to that value with 2 cells. So for example, if this was 1, 2, that would sum to 3. We'd put a 3 here, but now we'd have no way to sum to 3 over here. Let me fill out the 1, 2. Because the only way to sum to 3 in 2 digits is 1 plus 2. 4 has the same issue. We'd have to be 1 plus 3, and then we'd have to have another 1, 3 over here. So the only options are 5 and 6. 5, we can do 1, 4 with 2, 3. 6, we can do 1, 5 with 2, 4. Now, if you think about it, where does this digit, we're going to call that green, just to demonstrate here, where does green go in this row? Because we know it doesn't repeat in the column, and it also can't be part of its own sum, because we don't have a 0. We'd have to do like 0. If this was 5, how would we add to 5 using a 5? We'd have to do 5 plus 0, and there's no 0. So it's not going to go on its own sum, and it's not going to go in its own column. And so this is the only place that that green 5, 6 ends up. In this box, it ends up exactly here, actually, because it can't go on this. This is the same sum as this and this. So green can't go on there. Can we continue? I mean, green's one of these two. Green's up here somewhere. So I guess what's interesting is that whatever this digit is, it's also on this sum over here. So I guess the conclusion is that whatever these two add to is the same as whatever this plus the non-green add to. So like, let's just say this was the green, just for demonstration. If this ended up being the green 5, 6, then these two would add to these two. It would be the same sum because the greens cancel each other out. Anyway, we don't know if that's true or not, but I mean, we don't know where that green ends up, but that's always going to be true. But I don't know how to use that at the moment. Okay, so we do know what this digit's going to be depending on the 5 or 6. If this is a 5, then if you think about it, we're going to have 1, 2, 3, 4 across here. This is going to be 5. The only place for 6 is right here. And so this would be a 6 if that's 5. If this is 6, then you can't put a 3 on this sum, and this ends up a 6. And so this has to be the 3. So I guess a conclusion there is that one of these two is a 6, leaving out 6 from the rest of the column. So this black dot maybe then? This black dot, so let's think about black dots for a second. There's going to be a low digit, which is going to be 1, 2, or 3. Like whichever one of these digits is lowest, let's say that's this one. We don't know the order, but let's just call this the lower digit, which means this is double it. So if this was a 1, we could double it to 2. If this was a 2, we could double it to 4. And if this was a 3, we could double it to 6. But a 4 would have to double to 8, and 8's not in the puzzle. So 4 cannot be the lower digit. The lower digit is 1, 2, 3, and the higher digit is 2, 4, 6, meaning we either have a 1, 2, a 2, 4, or a 3, 6. Now you'll notice that because we have the 6 in one of these two, and this is a 3, 6, for both reasons, we can't put a 3, 6 across here. So we're left with either 1, 2, or 2, 4. Now that could be in either order, but it always involves the 2. So the rest of the column, we know 6 is in one of these two. So either this is a 6 or it's a 5, which puts a 6 there. And we know 2 is in one of these two. So these are not 2 or 6. So these are from 1, 3, 4, 5. And that's not a 5. So 5 is in one of these two. Okay. Maybe I should think about this black dot. So again, it's either 1, 2, 2, 4, or 3, 6. Okay, I can immediately rule out 2, 4. Can I? I'm not sure. Well, let's think about this a little bit. Let's think about this in context here. Okay, so whatever green is, this sums to green. So these 3 cells together will sum to an even number. That's what I'm trying to say. So this adds to green, that's green. We get an even number here. And in fact, we summed either 10 or 12. That might be important to give a number to it. So if these sum to 10 or 12, then we know the entire box sums to 21. That means these sum to either 11 or 9 or 11, I suppose. So if these sum to 9 or 11, I don't know much about this cell though. Is there a problem with 1, 2, 2, 4, 3, 6? Three, 6 is interesting because it forces this to be 5. So we know this adds to 10. This adds to 9. Sorry, 10 plus 9 is 19. So this would be a 2 exactly. So 3, 6 would put a 2 here. Okay. What does 1, 2 do? 1, 2, there's 2 options for 1, 2, but let's see what actually works. So this could add to either 13 or 15. If it added to 13, we would be missing 8 to get to 21, so that doesn't work. So we would have to, 1, 2 requires this to be a 6, so that we get 12 plus 3. Okay, wait, hold on. There's another problem with this being 1, 2 with 6. Oh. So I think 1, 2 just doesn't work. Let me explain why 1, 2 doesn't work with 6. Because 1, 2, 6, this would have to add to 6. But adding to 6 requires a 1 or a 2. It's 1 plus 5 or 2 plus 4. So if this is a 6, this can't be a 1, 2 pair. So it would have to be a 5. They'll make this add to 10. This would be add to 13 in total. And so this digit would have to get us from 13 to 21. And that would have to be an 8, which isn't in the puzzle. So 1, 2 is just not going to work. What about 2, 4 then? 2, 4 is interesting for this row. This is what I was trying to think of earlier, and I didn't quite get there. But 2, 4, that's 2 even numbers. And I can also already tell you that a white dot is going to contain an even number. So this would have to have the 6, and that's completely broken. So with 2, 4 gone, you can't do 1, 2. You can't do 2, 3. You can't do 3, 4. You can't do 4, 5. The only option is 5, 6, but we can't do 5, 6 because of this guy. So that just doesn't work. We can't do 2, 4 because of the row. So this actually is 3, 6 because it's not 1, 2. It's not 2, 4. It is 3, 6. That makes all of these 5. And actually, we know what we know that this is going to be 1, 4 because the 3 is gone. And that leaves the 2 right here. Okay, so that's not 2. Remember, 2 was in one of these two, so the 2 goes there. All right, that was good progress. Oh, and we know that green is 5, so this is the 5, and this is the 5, so we have this given. All right, don't need to call it green anymore, because we can call it 5. So what's kind of our next step here? Oh, with a 5, we know that this is 6. Remember, they were linked. Okay, so I need 1, 2, 3, 4 here. So we should know what this digit is. Because we know that this adds to 5. Why do I know that this adds to 5? Well, this adds to 5. And it's going to use a 1, 2, 3, 4 for 5. These two are the other 1, 2, 3, 4. So that's also going to add to 5. I'm explaining that. Okay. The 5 and 6 are already gone. So these two are the other two digits that aren't adding to 5 over here. And those happen to also add to 5. So if this adds to 5 and this adds to 5, and this is a 5, where's the 6 going to go? It's going to go right here. So this is 1, 3, 4. So the 3 is over here somewhere. So do we know anything about this sum? I haven't thought about it at all. So this is a 5. So 2 is gone. So the minimum sum here is 1, 3, 4. Is the first question to ask, is there a 6 on here? I'm not sure. Let's not ask that question. Let's actually just, let's min-max this maybe. So 1, 3, 4 is the minimum sum because we're missing the 2. And that is, 1, 3, 4 is 8. So that means these add to at least 8. So this is 3, 4, 5, or 6. It's not a 5. The 3's over here tell us it's not a 3 also. So it's 4 or 6. So we add to either 9 or 11. So we would know what the outie is then. If these add to 9, then this is another 7. That's 16. This would have to be a 5 as the outie, and that's not going to work. So I guess there's just no way to add to 9 right now. I guess with the 2 and the 5 missing, we can't do 1, 2, 6. We can't do 1, 3, 5. And we can't do 2, 3, 4. Yeah, there's no way to add to 9. So this is the 6. We add to 11. That's 3 and 6. So how are we adding to 11? Well, what's our outie? So 11 plus 7 is 18. So we need this to be a 3. All right. Which places the 3 down here? 3 in the corner, celebrating. This is 1, 2, 4. That's not a 2, so the 2 goes here. So this has to be the 6. And then this is 1, 4. Okay, what's going to resolve all this? This is a 3. Remember, these added to 5, so that's 3, 2. This is a 1, 4. Maybe it's this white dot or something. This is a 2, 3 then. We know the 2 and the 3. And this is a 1, 4. Well, something's going to resolve these 1, 4s. Yeah, so we have 1, 2, 4 left for the row. The 4 can't be involved in a consecutive sum like that. So this is no 3, no 5. So this is the 1, this is the 2. That gives us 4 and 1 and 4, giving us 1 and 4. Gives us the 1, 4, 4, 1, 4, 1. Then over here we have the 3 and the 6, and we're done. All right, 11 minutes, but I feel like it flowed. I just had a lot to explain as I went, I think. Very nice, cool. Very nice puzzle, Gene. I liked the flow of that. I liked how that worked. All the stuff with this box was really interesting, and I feel like that was a good thing to focus on. Cool. Well, let me know how you did, and if you enjoyed this, why not leave a like, subscribe, and a kind comment below.